Hello everyone. So in this lecture we will be discussing some numericals related to Vernier Caliper. As we have discussed this formula in our last lecture, but this formula is actually applicable only for verniers where MST is greater than VST. What does it mean? Each division on the main scale should be greater as compared to the one on the Vernier scale. Okay. So this is the division on mean scale. It should be greater than 1 on the Vernier scale. Only in this case, we can actually apply this formula right here. But if you need a method that works in every situation, we should return to the core fundamentals. How do we return to it? I have a method for that, which is known as the baby method. Okay. So now let's go to the question directly. And how do we apply it? First, we will be using the formula. So this is our question in which 1 mst is equal to 1 mm, 10 vst is equal to 9 mst. So just verify once quickly whether the mst is greater or not. For the same distance, I can fit 9 msd, but I need 10 vst to fit it, to fit the same length, isn't it? So what does it mean? Obviously it means that mst is greater than vst. Okay, so I hope that you understand this condition, and in that case we can apply our usual formula. Hence, solving by the formula, let's see what do we get. So what were the steps which we discussed? First, we need to check the zero reading, but zero error is already given, which is 0.3 mm. So next step is finding MSR. What will it be? Just before the zero of the Vernier scale, check the reading. What is it? 25 mm, because 1 MST corresponds to 1 mm here as given. Next we have VSR. How do we calculate VSR? N into the least count. What is the N? For that we need to find the coinciding division, which is this one. So 5, 6, 7. Seventh division into the least count. How do we find it? 9 MST is equal to 10 VST. We have already calculated this in our previous thing. So it is 0.1 mm, which comes out to be 0.7 mm. So this is our VSR. Now, what is our total reading? As we have already discussed this again, MSR plus VSR, 25 plus 0.7, 25.7 mm is the answer. Now let us solve by the baby method. I need your undivided attention here because this is very important, and with this method you can actually solve any kind of problem. I can be very sure about that. So now let's get on to our to this method. So this, as we know, is our main scale. It is the same problem, but I have just zoomed it so that you can have a better view. And this is the Vernier scale. Now this coinciding division becomes a reference. This is how we set our reference. Okay. And in order to find the actual measurement, note that actual measurement, I mean the total reading, total calculated reading. What we need to do is calculate everything till the zero of the Vernier. Okay, till the zero of the Vernier scale. This actually gives you the complete reading about the object which you have placed in between. But how do we find that? So what do we need? We are pretty much sure till this MSR, right? So this is our 2 point or 25 mm. What we need is this length, which I call it as X. So what will be my actual reading? So my total reading will be 25 plus X. But how do I find this X? How do I find this X? In order to find the X, I will consider this as reference. Orange line till my reference. this length minus blue line till my reference. If I consider these two lengths and I subtract them, so L1, L2, x is nothing but L1 minus L2, isn't it? Now, what is L1? L1 is nothing but one main scale division, second, third, fourth, fifth, sixth, seventh. So, this is L1 is nothing but 7 MST minus what is L2? L2 is nothing but on Vernier scale 1, 2, 3, 4, 5, 6, 7. 7 VST again. This is nothing but my X. So X is equal to 7 MST minus 7 VST. Now I have this relation again, 7 into 1 VST, but what is 1 VST? 9 by 10 MST. Hence, how can I write this? I can take 7 MST common. I can write this as 1 minus 9 by 10, which comes out to be 0.7 MST, but MST corresponds to mm, 1 mm. Hence, the value of X is 0.7 mm, and the total reading becomes 25 plus 0.7, which is 25.7 mm. I hope this is very much clear. Again, if you need to verify, you get the same answer with our formula method as well. Thank you.